This lesson is on solving a system of equations using the elimination method when the variables do not cancel out immediately. The elimination method is used when both equations in a system are in standard form. We can solve systems of equations by eliminating a variable. Adding the two equations together will eliminate a set of variables when their coefficients form a zero pair. A zero pair is a set of terms that have opposite coefficients, like 2x and negative 2x, or x and negative x. If a variable doesn't eliminate on its own, you have to use multiplication to create your own zero pair. In this first example, I look at each set of variables. The x's do not have opposite coefficients. Neither do the y's, but the y in the first equation is positive and the y in the second equation is negative. So is there anything I can multiply the first equation by to make the opposite of negative 3? The answer to that is 3. So the elimination method says that I can multiply the entire top of my equation by 3 so that I can add my two equations together. So I'm multiplying the top equation by 3. Everything gets multiplied by 3. 3 times x is 3x. 3 times y is positive 3y. And 3 times 3 is 9. I'm going to rewrite that second equation underneath. And now I can add my two equations together. It's just like combining like terms. 3x plus 2x is 5x. 3y plus negative 3y cancel out. It's the whole point of the elimination method. And 9 plus 16 is 25. Now we have our one-step equation to solve. We divide both sides by 5. And x equals 5. Now we can follow just like we did in our substitution method. We've got one part of our solution. I'm going to take that part and replace it in one of the original equations. This one has less stuff going on with it, so that's the equation that I'm going to use. So I rewrite it. I put my 5 in for x. And I have a one step to solve. I subtract 5 from both sides. Y equals negative 2. So the solution to this system of equations is 5, -2. Remember, this is the point that works for both equations. It's the point on a graph where the two lines would cross. At this time, pause the video and try the "you try" question right next to this example in your notes. Did you do it? Great. In example 2, I see that neither my x's nor my y's have matching coefficients or opposite coefficients, but the y term on top has a negative in front of it, and on the bottom has a positive. So they're already opposite signs. Is there anything that you can multiply 2 by to get 8? The answer to that is 4. So I can multiply the entire top equation by 4. So 4 times 5x is 20x. 4 times -2y is -8y. And 4 times -15 is -60. Now I rewrite my bottom equation. And I'm ready to add. 20 plus 3 is 23x. The -8 and y and the positive 8y cancel out. -60 plus 37 is -23. I divide both sides by 23. And the x value of my solution is -1. I'm going to take that -1 and put it back into one of my original equations. The less negatives, the better for me, so I'm going to use the second equation. So I rewrite that equation. 3x plus 8y equals 37. Now, instead of the letter x, I have -1. I multiply. And now I have a two-step to solve. So I add 3 to both sides. So that 8y equals 40. And then divide both sides by 8 to get my solution of 5 for y. So my final solution to this system is -1, 5. Pause the video and try the "you try" right next to this example in your note sheet. Hope you did it. In example number 3, I noticed that the y terms are opposite, but there's nothing that I can multiply 2 by to get negative 3. So I'm going to check the x's. This x has a 1 in front of it. I can multiply the second equation by negative 4. And this is important. Okay? It has to be the opposite, so it's got to be negative 4. And this time the x's will eliminate. So I'm going to rewrite my first equation, because I'm not doing anything with that. 4x minus 3y equals 12. Then I multiply. Negative 4 times 1x is negative 4x. Negative 4 times positive 2 is negative 8. It multiplies y. And then negative 4 times 14 is negative 56. Now I can add my two equations together. 4x plus negative 4x cancel out. Negative 3 plus negative 8 makes negative 11. Don't drop the y. Then 12 plus negative 56 makes negative 44. I divide both sides by negative 11, and y equals 4. I'm going to take the 4 and put it back into one of my original equations. I'm going to use the first one, or the second one, because it has no minus signs. So x plus 2y is 14. I'm going to replace the letter y with 4. So x plus 8 is 14. Subtract 8 from both sides, and x equals 6. So the solution is 6, 4. At this point, we are done with this lesson. On your own, do the you try for example 3 and both example 4 and the you try. Ask for help if you need it.